product of two functions. Now what is that product and what all those things we'll discuss now. Okay, that is now just a minute. Somebody, I think somebody. Okay. Okay. See here. If two functions f of t and g of t are there, they're usually denoted by convolution of those two are denoted by f of t. We read this one as f of t convolute f of g of t or f of t into g of t, and is defined as f of t into g of t is equal to integration u is equal to 0 to t. See, u is equal to t is changed into u is equal to 0 to t f of u into g of t minus u du. This is we denote a convolution of those two like this given functions. Then and one more thing is convolution is commutative. That is, if you want you can take g of t first. If you want you can take g of t first, and if you want you can take f of t first. No issues. As situation demands, as per your convenience, you can take whichever is the first one. That is commutative means a into b is equal to, you can write b into a. That is a commutative property. Okay, so convolution is a commutative, that we will discuss later. Okay, is that clear? So now we need to learn much about the convolution, one of the theorem which is called convolution theorem relating to inverse, finding the inverse. Okay, now convolution theorem says that if L inverse of f bar s is f of t, already you know it, and if you take another function L inverse of g bar s is g of t, then L inverse of this f bar s into g bar s, L inverse of f bar s into g bar s, it is given by integration u is equal to 0 to t f of u g of t minus u du. See, this and this are one and the same, because see, f of t is L inverse of f bar s, and g of t is L inverse of g bar s. L inverse is taken outside and it is applied to this. Usually what happens, what I told, linearity property. Usually linearity property, if it is a L of f of t, I told you, if it is L of f of t into g of t, it is, you cannot apply according to the linear property. You cannot take separately the you cannot apply this L operator separately to this into this. That is L of f of t into L of g of t. It is not applicable. You have to convert this in terms of sum or difference. Then you can apply inverse. You can apply Laplace operator according to the linearity property. But according to the convolution theorem, what we can do, if it is a product also, you can take outside and you can, using this integral, you can find out how to use this integral. All those things we'll discuss. Okay, you can find out the inverse of a product of these two given functions. Okay, now here evaluation of the inverse transform by using convolution theorem. Just 1 minute. Okay, now see here, method to solve the problem. So method to apply this theorem to find the inverse of the given function. We'll discuss that now. Now the given function is expressed as a product of two functions, say f bar s and g bar s. Your function will be given in terms of s, and you should express those function in terms of product of two functions, as a one should be taken as f bar s, another should be taken as a g bar s. And after taking f bar s and g bar s, after expressing your function as f bar s and g bar s, what you should do, we have to find the second step is we have to find the inverse of that f bar s and g bar s. Means you have to express this s function in terms of t, this x function in terms of t. That is the second stage. Now third stage, you have to apply the convolution theorem in one of the forms I have written here. In one of the forms means either you can take this form or you can take this form. That is either you can use f of u first or g of u first, or you can use second g of t minus u or f of t minus u. Both are valid. And after that, what you have to do, after that you have to evaluate this integral after making these manipulations. Now the question is, sir, you may ask one question here. Sir, here you are taking a g of t and f of t and you are taking a u here y. So what you have to do after finding f of t here, what you have to do? Change, you are integrating this with respect to, that's it. Change t to u in the first function, and in the second function, if it is a t is there, change t to t minus u wherever t is there in g of t, then substitute here, and then the limits becomes u is equal to 0 to t, because you are integrating with respect to u. You are integrating with respect to u. Is that clear? Is that clear? Then as usual, whichever method is applicable, standard forms using the standard integrals, you can evaluate this integral. Usually 99% or 95% you can say, usually 95% we are going to use this form only. In rare case, we are going to use this form. Okay. So we need to remember this. So what is your convolution theorem? L inverse of f bar s into g bar s is equal to u is equal to 0 to t f of u into g of t minus u du, where f of u got from f of t by replacing the t is equal to u, g of t minus u you got from this g of t by replacing wherever t is there, by replacing that t by t minus u. And you can also say that this is equal to, this will be equal to f of t into g of t. Okay, f of t into g of t. Finding the inverse means finally this function is expressed in terms of t. So this is product of two functions. Is that clear? Is that clear?
Yes, sir.
Okay, we'll take some important examples today. We'll conclude this. Okay, we will take some important results or important examples. See what they say: using convolution theorem, obtain the inverse Laplace transform of the following function. Many examples are there. So instead of writing again and again, use the convolution theorem. I have written only one sentence. Okay, is it okay? First example is find the inverse of this function. This is in terms of s, inverse of this function using a convolution theorem. Sometimes they may not give this using convolution theorem, but by observing this you can decide you can use the convolution theorem. Now if they do not give, you may ask, sir, if they do not give, how we are going to recognize whether convolution theorem is applicable or not? See, here in the numerator you have one, in the denominator you have product of two functions. So of course you can use your partial fraction method, but it becomes very lengthy, very difficult. See, partial fraction method, if you want to use, what you have to do, you have to concentrate on the denominator. Of course it is a proper fraction. If you concentrate on this, two factors are there. This is s, this is a s square plus a square. This you can say s minus 0 raised to 1, which is a linear factor, and this is a non-factorable factor. So what you can write, you are going to write this one as, if you want to use, I am not talking about convolution, if you want to use a partial fraction method, you are going to write this one as a by s plus you can write this one as a bs plus c divided by, you are going to write this one as a s square plus a square, s square plus a square. So next what happens, you need to take the LCM, you need to multiply this by this, you need to multiply this by this, then you have to compare the coefficients, then you have to find the value of ABC. That becomes a very complicated one. So instead of that, if you have product of two functions in the denominator, product of two functions in the denominator, now directly you can go for, if they do not give also, directly you go for convolution method only. We'll see how to solve this by convolution method. Now what we have to do, observing this denominator, consider this entire function. This is your f bar s. Therefore L inverse of 1 divided by s, you have to find inverse, no? So we have to write this L inverse of 1 divided by s into bracket s square plus a square. Now see here, this is into there, so properly we have to choose, we have to split or we have to express this in terms of two functions, so that if you multiply those two functions, this original thing should remain as it is. So what we will do, we will take let f bar s, let us choose it as 1 by s, and g bar s, let us choose it as 1 divided by s square plus a square. So that if you multiply these two again, you will get 1 by s into 1 divided by s square plus a square, which will be again 1 divided by s into bracket s square plus a square. So we have chosen 1 by s as a f bar s, remaining term, that is 1 divided by s square plus a square as a g bar s. Now what is the next step? You have to find f of t. That is, you have to find L inverse of f bar s. F of t is equal to what? Equal to L inverse of f bar s. You have to write. What is your f bar s? F bar s is 1 by s. You have written here. Therefore, L inverse of 1 by s is 1, because you already know that L inverse of 1 divided by s raised to n plus 1. S raised to n plus 1. This is what? T raised to n divided by n factorial. If you compare this to n plus 1 here, it becomes n plus 1 is equal to 1. So n is equal to get 0. Therefore, t raised to 0, 0 factorial is already, 0 factorial is already, you know that 0 factorial value is 1. So you can write a t raised to 0 is 1. So L inverse of 1 by s is 1. If you remember this is well and good. Otherwise, if you remember general formula, then directly you are going to get this value. Now you got a f of t value. F of t is what? 1. Okay. Next, so what you have to do here? According to here only we can write. Therefore, f of t, once you got, I have not written it, but you can find here only. F of t, if you got, directly you can write f of u here. So f of u, wherever t is there, changing t to, wherever t is there, you have to change that t to u, but t is not present here. So you can write f of u is 1 only. F of u is 1 only. Is that clear? First or example will go a little bit slow, then we will increase the speed, okay, so that you can understand it much better. Next, to calculate g of t, you have to find the inverse of this, okay, that is L inverse of g bar s. L inverse of g bar s is L inverse of 1 divided by s square plus a square. L inverse of 1 divided by s square plus a square can be written as 1 divided by a into sine 80 or sine 80 divided by t. So this is your g of t. Okay, this is by using the standard results. Now what you have to do to use the convolution theorem, I have not written here, but for your convenience in the examination, what you do directly here only you calculate so that it becomes easy for you. G of t minus u, that is changing in the second part, the inverse of the second function, changing t to, changing wherever t is there, changing that t to t minus u. So you will get this one as a sine yes, a into bracket t minus u, a into bracket t minus u whole divided by this a as it is. If you take this a inside the bracket, you will get a sine at minus au, sine at minus au. Once you got this, we have by the convolution theorem, what your convolution theorem says, L inverse of f bar s into g bar s is equal to, first you write this, u is equal to 0 to t, f of u into g of t minus u du. Now substitute this value and this value which you have obtained here and here. So what you will get? So therefore L inverse of f bar s into g bar s is L inverse of 1 divided by s into bracket s square plus a square, which is equal to integration u is equal to 0 to t. So first I'll write it. If you ignore this one also okay, but for understanding purpose I have written here f of u value is 1, which you will write here. G of t minus u becomes sine at minus au divided by a. This is with respect to u. You need to concentrate on this. Whenever you're integrating with respect to u, t is treated as a constant term. Next. So what happens? This is 1. So integration, you will have to the only integration u is equal to 0 to t sine at minus au divided by a with respect to u. So 1 by a is constant. I'll take that outside. Then I'll integrate this part. Only this part, sorry. I'll integrate this part. If you integrate sine at minus au, what is integration of sine? Integration of sine is minus cos angle as it is, that is at minus au. You are integrating with respect to u, means the coefficient of u should be taken in the denominator, that is minus divided by minus a, you will get. Is that clear? Is that clear?
Yes, sir.
Okay. So here what happens? Minus divided by minus, minus divided by minus, it becomes plus, then 1 by you will take this a outside, so it becomes 1 divided by a square. So I have written here 1 minus cos 80. How you will get this 1 minus cos 80? We'll check that here. See, I'll write here. If you take that a outside, minus divided by minus, it is plus a outside, so 1 divided by a square, it becomes this step I'm talking. Okay, then this you left with only cos 80, cos 80 minus au. I'm sorry, cos of 80 minus au. Now you put upper limit first. You put upper limit cos. What you will get? Upper limit is cos. You will get if you put t is equal to, sorry, u is equal to t. You will get cos 80 minus 80. This is upper limit. Okay. Then minus lower limit. You put lower limit is 0. Wherever u is there, you have to put that 0. So you will get minus. You will get cos 80 minus 0. Okay, so what happens? So here you will get cos 80 minus, cos 80 minus 80 is, this is 80, 80 get cancelled, so you will get a cos 0 value is 1, minus cos 80 minus 0 is cos 80, so you will get this as cos 80, so you will get this as 1 minus cos 80. So the inverse Laplace transform of this function, that is 1 divided by s into bracket s square plus a square, is you can write this one as 1 minus cos 80 whole divided by a square, whole divided by a square. This is by using the convolution theorem. Is it becomes easy or not? If you keep on finding, if you keep on splitting this into partial fractions, it becomes very, very lengthy. Okay, you have to find a, you have to find b, you have to find c, then you have to go back, then you have to substitute, then you have to apply term by term inverse operator, then you have to get the answer. Instead of that, if your denominator is a product of two functions, if your denominator is product of two functions, what you have to do? You have to use a convolution theorem like this. Is that clear? Are you going to remember this convolution theorem?
Yes,
Are
sir.
you? Okay. Shall we go for the next example now? Shall we go
Yes,
for?
sir.
Okay. Thank you. Okay. Next example is find the inverse of Laplace transform of this function using a convolution theorem. So your function is s divided by s square plus a square whole square. See, is it possible to use any other method here? Previous methods which you have learned? No, it's not possible. Of course, you can use partial fraction method, but what you have to do? It is a repeated factor, that too non-factorable repeated factor. So it becomes very, very difficult to use the partial fraction method. So we can think of using a convolution theorem. So to find inverse of it. For that purpose, what you will write? L inverse of s divided by s square plus a square whole square. You will write down this first. Then you have to split this into two parts. In the numerator you have s, in the denominator you have s square plus a square whole square. Either you choose this as a f bar s, this as f bar s, no need to worry. So what we will do, we will choose f bar s as choose f bar s as 1 divided by s square plus a square, and g bar s as s divided by s square plus a square, so that if you multiply these two again, this original thing remains as it is. Is it remains as it is or not? First step this is okay, always. Then after choosing this f bar s and g bar s, then find the inverse of this f bar s. That gives you f of t. That is f of t is equal to L inverse f bar s. That is L inverse f bar s means 1 divided by s square plus a square, which is sine 80 divided by a. Sine 80 divided by a, or you can read it as 1 by a into sine 80. Now uh, find the what is that? See, I forgot to say here, 1 minute. If you want in the examination, you can directly write down here by changing the t to u. You can directly write down your f of u. Your f of u becomes yes. What becomes it is t is equal to, you have to put u, sine au divided by a, sine au divided by a. Then to find g of t, take the inverse of g bar s, that is L inverse of g bar s is equal to L inverse of s divided by s square plus a square, which is the standard result. L inverse of s square s divided by s square plus a square is equal to cos 80. You can write, if g of t is, if g of t is cos 80 means yes, g of t is cos 80 means what happens? We require g of t t minus u. G of t minus u becomes what? Can anybody help me out here? This becomes, wherever t is there, you have to put t is equal to t minus u. So it becomes cos at minus au. Am I right? At minus au. Now you got your f of u, you got your g of t minus u. So by the convolution theorem, we have L inverse of f bar s into g bar s is equal to integration u is equal to 0 to t f of u into g of t minus u du. Already which you got here, you substitute those values here. That becomes L inverse of s divided by s square plus a square whole square. S square plus a square whole square is equal to integration u is equal to 0 to t sine au divided by f of u is sine au divided by a, and g of t minus u becomes cos at minus u. Okay. Now 1 by a is a constant. I have written directly here, but I'll tell you 1 by a is a constant. You take that outside. Then if you take 1 by a outside, it is of the form sine a cos b. It is of the form what? Sine into cos. Directly you cannot integrate. It is of the form, say I'll write here. It is of the form sine a into, yes, sine a into cos b form. It is your a, this is your b here. So if it is sine a cos b, what you have to do? You have to use a transformation formula. What is that? Product to sum formula. So what is product to sum formula? It is sine a cos b, means you can write this one as 1 by 2 times. I'll write it simply here. 1 by 2 times, that becomes sine a plus b, sine a plus b. Then next what? Minus sine a minus b, sine a minus b. Okay. Therefore, this is your a, this is your b here. So what? I forgot to put one bracket here. I'll put here. So 1 by 2 is common to this. So I have taken that outside here. So that becomes 1 by 2a, 1 divided by 2a. Integration u is equal to 0 to t. Integration u is equal to 0 to t. U is equal to 0 to t. Then this is a sine. Be a little bit careful here. Sine a plus b. That is sine au plus at minus au. You will get sine au plus at minus au, because this is a, this is b. This b you have written here. Then plus whether I have written plus here, this becomes plus or minus. So I'm sorry, this becomes plus here. Plus. So what happens? Plus sine a minus b. Sine a minus b. Sine a minus b means sine au as it is minus of this. So minus of this means this becomes minus, this becomes plus. So you can write it as sine au minus at plus au. So simplify this. So what happens here? This au are with the opposite sign, so that cancels. So finally you'll get the first term as 1 divided by 2a as it is. Integration u is equal to 0 to t. Integration u is equal to 0 to t. Then this is a sine at. Then this becomes sine au plus au is sine 2au minus at as it is. Sine 2au minus at as it is. Is that clear? Is that clear? See, remember these formulas. These are going to appear in this convolution theorem frequently, often and often. Okay. Then what happens? So this is sine 81 term. This is sine 2au, 2 times au minus 80 other term, and you are integrating with respect to u. So when you integrate with respect to u, this term by term, what happens? 1 divided by 2a as it is. Sine 80, this is constant here. Sine 80 is constant, means what you will get? You will get integration of du with respect to this first term. So you can write it as a integration of du is u. So u is equal to 0 to t. Is that right? Clear? Sin 80 is held constant. You need to integrate only u term. So it becomes integration du if you integrate only first term. So that is u. So u is equal to 0 to t. We put this separately limits. Then next come to this. Integration of sine 2au minus 80. Sine 2au minus 80 means integration of sine is minus cos. So this plus into that minus becomes minus. So I have written minus here. Minus cos 2au minus 80 as it is. You are integrating with respect to 2 means u coefficient should be taken in the below, that is divided by 2a. Is that clear? Clear or not? Next, what you have to do? You have to put the limits here. 1 divided by 2a as it is. This becomes sine at as it is. If you put the upper limit here, t is equal to, sorry, u is equal to t, that becomes t, minus lower limit is u is equal to 0, that becomes 0, which are written here. That becomes, if you put the limits for u, it becomes sine at into t minus 0. So minus as it is. This 1 divided by 2a we have taken outside. This 1 divided by 2a we have taken outside. Now, what we will do, we will put the upper limit first here. If you put the upper limit, what happens? Sorry, just 1 minute. If you put the upper limit wherever t is, wherever u is there, you have to put t. So it becomes what? Cos 2at minus 80. That becomes cos 80. Cos 2at minus 80. That is cos 80. Then minus lower limit. What is your lower limit? Lower limit is 0. Wherever u is there, put 0. So that becomes what? Cos 0 minus 80, but cos of minus theta is what? By the standard property, cos of minus theta is cos theta only. So this becomes, this minus remains as it is. So it becomes cos 80. So plus cos 80 minus cos 80 get cancelled. So entirely this term becomes 0. You left with only these two terms. So multiply these two, what you will get? Yes, you will get t into sine 80 divided by 2a, which is the inverse Laplace transform of this function. Is that clear? This is the advantage of using convolution theorem. Is that clear?
Yes, sir.
Are you understanding or not convolution theorem? Because one example definitely comes in your V2 examination on this. Is it clear? Is it clear? All of you?
Yes, sir.
Okay. Next, we will take one more. All these examples are very, very important, and all these examples have been asked in your examination previously. So, next one is find the inverse of this function using convolution theorem. That is 1 divided by s square plus a square whole square. So, L inverse of 1 divided by s square plus a square whole square. So, you have to express this as a product of two functions f bar s and g bar s. So choose means choose properly f bar s and g bar s. So your numerator is 1 means definitely you are going to get in both the numerators 1. So you can write it as a f bar s is equal to 1 divided by s square plus a square, and g bar s be 1 divided by s square plus a square. So quickly, immediately after getting this, quickly you have to find f of t. Therefore f of t is equal to, you already know L inverse of f bar s. So f bar s is 1 divided by s square plus a square. So L inverse of 1 divided by s square plus a square is equal to 1 divided by a into sine 80. Similarly, g bar t is equal, sorry, g of t is equal to L inverse of g bar s. G bar s is already, you know, that is L inverse of 1 divided by s square plus a square. This is also 1 by sine 1 by a into sine 80, but this becomes wherever t is there, you have to replace it by u, so it becomes f of u, that is 1 sine a u divided by a, and here wherever t is there, you have to replace that by, yes, changing t to t minus u. Please keep in mind, don't multiply this one, don't keep answer directly, please. This is your f of u, this becomes changing t to, so it becomes sine AU divided by A. It becomes sine AT minus AU divided by A. Therefore, once you got those, we have to write by using convolution theorem, L inverse of f bar s into g bar s is equal to u is equal to 0 to t, f of u into g of t minus u du. Please remember this. Please remember this. Then substitute this value here. So that is L inverse of 1 divided by s square plus a square whole square. If you don't write this also okay, because already you have written here and already you have considered these two terms here, no issues. Better to write this. Okay, then this is equal to u is equal to 0 to t, f of u is sine au divided by a, and g of t minus u is sine at minus au divided by a with respect to u. Now here in the denominator you have constant terms, so take that constant outside, so that becomes 1 divided by a square into, this will be of the form sine a 1 minute. This will be of the form, this will be of the form sine A into sine B. Okay. So both are sine means one standard rule which you are going to rule, which are sum to product, sum to, sorry, product to sum, which rule you are going to use? 1 by 2 times. Definitely that will be in terms of cos. So you will get cos, cos, yes, it is what? A minus B, because cos A minus B means you will get cos A cos B plus sin A sin B, and this is minus you will get cos A plus B, cos A plus B. So that what you will get here, if you take cos A plus B, cos minus cos A cos B, for this you will get cos A cos B minus sin A sin B. If you take this minus sign inside, that becomes plus sin A sin B. So 2 times sin A sin B will get here. To manage that 2, we want value of this, so we have taken this 2 divided by 2 here. So applying this formula, taking this as A, taking this as B, you will get 1 divided by 2. Already we have this 2 already we have taken outside here. A square is already there, therefore 1 divided by 2 A square into u is equal to 0 to t. Put one bracket here. U is equal to 0 to 2, because this integral sign is relating to both the terms, and this du is relating to both the terms. Okay, therefore what happens? Cos, you have to write a minus b here. Cos a is this one, this is b. Cos of au minus of this means it becomes minus 80 plus au. Take minus sign here, it becomes minus, this becomes plus, which we have written here. Then minus cos a plus b. So this is a, au plus b. How you are going to write? Plus b. Yes, plus b means this is, I'm sorry, this is minus a, this is plus. Okay, cos au plus at minus au you will get, so that this au get cancels, then this at remains. Due to some typing mistake, it has come minus here, so make it plus, this becomes minus, because if you take directly here, this is a plus b, this is au plus 80 minus au plus au get cancelled, so you left with only cos 80 here. So if you simplify here, what happens? This becomes 1 divided by 2 times a square, as it is integration u is equal to 0 to t cos au plus a is 2au minus 80, as it is, minus this is cos 80 du. So integration of now you have to integrate this. Integration of cos is sine 2 times au minus 80. You are integrating with respect to du, means you will get divided by 2a u is equal to 0 to t, minus here you are integrating with this term, you are integrating with respect to u. Cos 80 is kept as it is. Then it becomes integration of du only. Integration of du is what? Integration of du is u is equal to 0 to t. Now we will start putting the limits. So here 1 by 2 again, 1 by 2 a I will take outside. This you keep as it is. Don't forget to keep this 1 divided by 2 a as it is. Now in this part, only this part. So we will start putting the limit here. Wherever u is there, put t. Sine, you will get sine. What you will get there? Sine 280 minus 80, which will become sine 80. Okay, which will become sine 80. I'm sorry. Then next, I have written plus here. So actually, what you will get there? Sine, lower limit, sine minus of, if you put u is equal to 0, you will get 0 minus 80, lower limit I am talking. Then sine of minus theta is, I'll write here, sine of minus theta is, this is minus sine theta, minus sine theta. So it becomes sine of minus 80 is minus of minus sine 80, minus of minus becomes plus sine 80. So I have written here plus sine 80. Is that clear? Next, cos 80 as it is. If you put the limit here, if you put the limit for this u is equal to t, that becomes t minus 0. T minus 0 is t only, so I have written directly t here. So finally you got this. Now sine 80 plus sine 80 is 2 times sine 80, 2 times sine 80. So I have written here 1 divided by 2a cube, 1 divided by 2a cube into sine 80 minus 80 cos 80. Why I have written this? So I'll write one step extra here. Please observe. Just don't make it a jumbled. If you have any confusions, any difficulties, if you are feeling difficulty, please ask the questions. Okay. Now this step I'll tell. I will get the final answer. Okay. Now this step you observe here. 1 divided by 2 a cube is a square is already there. Okay. Into bracket you will get 1 divided by 2a into you will get here sine 80 plus sine 80 is 2 times sine 80 you will get minus minus t into you will get cos 80 as it is. Okay, the next this two get cancels. I am this a is relating to only first term, so I am taking this sine, sorry, this a outside. If you take this a outside, you should take LCM here. If you take the LCM here, it becomes what? If you take LCM here, you have to multiply this by a, so you are written here, taking a common, it becomes 1 divided by 2a cube, and it becomes sine 80 minus, you are multiplying it by a, it becomes a into t into cos 80, which is the required answer. Hope this simplification you understood. You understood or not? Okay,
Yes,
I'll
sir.
write this. Then we'll go for the one more example. So today we'll try to complete this. Okay. So next, this is one of the very important example which has been asked very recently in your question paper. So find the inverse Laplace transform of, yes, this is example number 3 or 4. This is, sorry, this is example number 4. Find the inverse Laplace transform of s square divided by s square plus a square into s square plus a square into s square plus b square. Okay, now this is your given function. You have to find inverse of this using convolution theorem. Therefore, L inverse of s square divided by s square plus a square into bracket s square plus b square. So you have to choose f bar s and g bar s properly here. So s square is there in the numerator, means both the terms in the numerator are going to get yes. So you can write it as a, so that if you multiply you must get a square. Okay. So that is, let f bar s is equal to s divided by s square plus a square, and g bar s is equal to s divided by s square plus b square. Split this into two parts. Okay. Now, so that if you multiply these two again, original thing will remain as it is. Next, find immediately inverse Laplace transform of this. Inverse Laplace transform of this becomes what? That is f of t. F of t is equal to L inverse of f bar s is equal to, that is L inverse of s divided by s square plus a square is equal to, this is in the standard form. So what you can write, and this constant term is a square here, so you can write it as cos 80. Cos 80, f of t is cos 80 means f of u becomes, what is your f of u? Yes, wherever t is there, you have to replace that by u, so it becomes cos au. The next, L inverse of, sorry, g of t you have to calculate, that is the L inverse of g bar s is equal to L inverse of s divided by s square plus b square. In place of a, you are having b here as a constant term, so you can write this one as a cos bt. G of t is cos bt means g of t minus u. G of t minus u, what it becomes? G of t minus u is cos, I'll write here, cos, this is, yes, wherever t is there, you have to substitute by, change it by t to t minus u, so it becomes bt minus bu, bt minus bu. Now you got your f of u, you got your g of t minus u. Therefore, according to the convolution theorem, L inverse of f bar s into g bar s is equal to u is equal, integration u is equal to 0 to infinity f of u into g of t minus u. So therefore, this value substitute s divided by s, L inverse of s square divided by s square plus a square into s square plus b square is equal to, this is integration u is equal to 0 to t, f of u is cos au, g of t minus a is cos bt minus bu. Now, if it is a plus or minus here, you would have different, sorry, you would have integrated separately and you would have written the answer directly here. But it is of the form, it is of the form cos a cos b. It is of the form cos a into cos b, product of two terms. So you have to use product to sum formula. What you will get? 1 by 2 times cos, both are cos means in terms of cos you will get 1 by 2 times you will get cos a plus b, sin you should get cancelled, sin should get cancelled here. So cos a plus b plus you will get cos a minus b, cos a minus b, cos a minus b, or you can write this first, no issues. You can write this first or this first, you will get same answer, that is cos a cos b minus sin a sin b plus cos a cos b plus sin a sin b plus sin a sin b minus sin a sin b get cancelled. You will get 2 times cos a cos b here. So using this formula 1 by 2 I already taken outside here. U is equal to 0 to t cos a plus b. A is au here, b is bt minus bu. So you will get cos au plus bt minus bu, then plus cos au minus, sorry, cos a minus b. A is au here, I'll write it. Therefore, it becomes cos au as it is. Minus of this means you will get minus bt plus bu. This is your angles now. Okay, be a little bit careful. Then now next what happens? See, you have split it into sum of two terms here. So just for our convenience, we will rearrange this so that integration becomes easy. So we'll write this one as a 1 by 2 as it is. Integration u is equal to, directly from this step you can write this step, but for understanding purpose I have written this step extra here. That is 1 by 2 times u is equal to 0 to t cos au minus bu, or you can write this one as cos a minus b into u plus bt. We write au minus bu plus bt plus cos au plus bu minus bt. This is with respect to u. So integration of cos, don't worry about this angle, you will think of this later. Cos, integration of cos is sine, we have written here, plus sine we have written here. That angle is au minus bu plus bt. You are integrating with respect to t, means constant terms coefficient of u should be taken in the denominator. That is, if you take u common here, that becomes a minus b. So we have written here a minus b plus, sorry, u, I am sorry, limits are 0 to t, u is equal to 0 to t. Next, again cos integration is sine, angle is au plus bu minus bt. So if you integrate with respect to u coefficient becomes here a plus b. Therefore integration of this becomes sine au plus bu minus bt divided by, this is a plus b, limits are u is equal to 0 to t, limits are u is equal to 0 to t. Is that clear? Therefore, now start putting the limits here. See, 1 by 2 keep as it is. Then a 1 divided by a minus b is a constant. I'll take that outside. Now I'll start putting the upper limit here. If you put the upper limit wherever u is there, put u is equal to t. So what it becomes? Upper limit sine at minus bt minus plus bt you will get. So this minus bt plus bt get cancelled. So you will get only sine at, which we have written here. Upper limit. This is upper limit. Minus lower limit. What is your lower limit? Lower limit is put u is equal to 0. If you put u is equal to 0, what happens? This becomes 0. This becomes 0. You left with only bt. So minus sine bt you will get, which you have written here. Okay, this is over. Next, plus. Here you have to put the limits, upper limit and lower limit, by the definite integral properties. So 1 divided by a plus b is constant. I have taken this outside. Then put the upper limiter. Wherever t is there, you put, wherever u is there, you put t. If you put u is equal to t, this becomes sine at plus bt minus bt. Plus bt minus bt. Again, this get cancels. You left with sine at, because you have substituted t is equal to, u is equal to t here. So it becomes sine at, which you have written here. Then next, put the lower limit. If you put lower limit as 0, then what happens? If you put the lower limit as 0, so this is 0, this is 0, these two terms will become 0 when you put the limit. So it becomes sine of minus bt. Sine of minus bt is minus sine bt. It is lower limit. So minus of minus, it becomes plus sine bt, which you have written here. Next, further simplification is required. Okay. Further simplification, how we are going to do here? Further simplification, very simple simplifications are there. Further simplification, see, I'll tell you. So here, what we will do? See, I have written here sin 80 into bracket 1 divided by 1 minus, a minus b plus 1 divided by a plus b. This is because, see, here also sin 80 is present. Here also sin 80 is present. From these two terms, I will take sin 80 common and you left with 1 divided by a minus b from this, 1 divided by a plus b from this. Next, see, observe, here also sin bt is present, here also sin bt is present. From these two terms, I will take sin bt common. So from this term, you left, this is the negative sign, this is the positive sign, so I written plus first here. So from this term, you left with a 1 divided by a plus b, and from this term you left with, you are taking plus sin bt, so you left with a minus 1 divided by a minus b common. So after this, what you have to do, you need to simplify it further. How you are going to simplify it further? This sin 80 you keep as it is. Sin 80 you keep as it is. Now for this, take the LCM. LCM will be what? LCM will be, I'll write here, LCM will be a minus b into a plus b. If you take the LCM, a minus b into a plus b, you will get, then what you have to do? You have to multiply this with this with this. So you will get a plus b plus a minus b. I'm sorry, plus a minus b you will get. So this b get cancelled. So you will get in the numerator you will get 2a divided by a plus b into a minus b means a square minus b square. Similarly, here also you need to take the LCM, but here it is with the negative sign. If you take the LCM here, again I'll write it directly. It becomes a plus b into a minus b, which is a square minus b square. But here what happens? You have to multiply this with this with this, so it becomes a minus b. Then minus of a plus b means you will get minus a minus b plus a minus a get cancels. So you get minus 2b, which we have written here. So immediately after that, what you need to do? So you observe here. So please observe. So it is this two you will take inside. This two, this two, this two, this two get cancelled. Taking two common. This is one term. It is not the angle. Okay. From I'll tell it clearly. Just one. From this term and from this term. Okay, we will take two common, two to get cancelled. So you left with a divided by a square plus a square minus b square. Here minus b divided by a square minus b square. So again 1 divided by a square minus b square you can take outside. You can write it as a into sin 80 minus b into sin bt. This is the required answer. Your final answer is 1 divided by a square minus b square into bracket a sin 80 minus b cos bt. So inverse Laplace transform of this function is 1 divided by a square minus b square into a sin 80 minus b cos bt. A sin 80 minus b cos bt. Do you have any difficulty with this? Convolution theorem is understood?
Yes, sir.
Okay. These many examples you please remember. This completes your convolution part. Okay. And all these examples are very, very important. Tomorrow, one more class I require to complete this Laplace transforms. Okay. Everybody has completed, but still I am lagging behind. Anyway, tomorrow will complete. See, please remember all the techniques to finding the inverse, because finding the inverse technique by partial fraction method or by using convolution theorem or by using shifting property reverse way, all these are going to helpful when you go to solve the differential equation in the next part. Okay, differential equation in the next part. Is that clear? So please practice little bit, because almost we have done, we have completed 90% of the your first model of transform calculus. That is, what is your subject name? Do you remember? What is your subject name which I am teaching now? Subject name, I am not asking topic name. Subject name, what is your subject name?
Engineering
Yes.
mathematics.
No, subject name. What I told when I took first class on the board.
Transforms calculus and Fourier series.
Transform calculus, Fourier series, and numerical techniques. Is it? Subject code is 18 mat 31. From the in that model 1 is almost done. Only 10 to 12% is remaining, which we are going to complete tomorrow. So please tell me whether you understood all these things or not. You understood? Please, what you do, you put your attendance here quickly so that it should be on record. Quick. Don't leave the meeting. Everybody has given. Everybody has given attendance. All the 54%. Okay. Let me stop recording.